So again, this is 2.1.2 day 1 lesson. So we've got our image off to the left-hand side, which is basically just a blank graph. And the reason why I did that is if you take a look at the table of values that I gave you, they go up pretty high in the Y direction. And I didn't want you to have to worry about writing out a graph that big. I wanted to give you something that was just the right size. So we're going to use that image off to the left, which is also linked in your agenda. So make sure you have it in front of you. So we're going to take this tile pattern. Tile pattern in this case is just a tool to get us to being able to write linear equations. So we're going to use this idea if we've got a figure number, which we are going to identify as X, and then the number of tiles, which is Y. If you take a look, we've got a figure number. We'll put an X on that X axis, and then the number of tiles. We'll put a Y on that Y axis. We're going to go ahead and plot those points. So we've got 0, 2. So let's do 0, 2. You'll notice the change in increments on the axes as well. So on the x-axis, I went by ones. So it's 1, 2, 3, 4. But on the y-axis, because the y values can kind of get pretty big here, I went by 2s. So it's 2, 4, 6, 8. So just be careful when you're plotting. All right, so we've got 0, 2. That's going to be our first one. Go ahead and plot that point. And then 1, 7. So go over to 1, but you're going to go, because the y is in increments of 2, you're going to go halfway between the 6 and the 8. So 1 and 7, so kind of right there. And then let's go ahead and just fill in the rest of the points. So 2, 12. And then 3, 17. So halfway between 16 and 18. And then 4, 22. And I think once everybody sees how big the y values are, understand why I wanted to give you the graph itself instead of you having to create it. So now what we want to do is we want to draw a line to connect these dots, but this is only a model of the pattern itself. So later this year, you and I are going to talk about when do I connect the dots versus when do I not connect the dots. That's going to be a topic of conversation for the future. For now, we want to connect the dots just because it is a model, all right? That doesn't mean that it's always appropriate, but in this case, we want to try to model something else. So we're going to go ahead and connect these dots here. Okay, after doing that, we know how to answer this question. Is it a function? Yes, of course it's a function. It passes the vertical line test. Every input has exactly one output. This is a definite yes. So, is it a function? Yes, it's a function. Every input has exactly one output. All right, write the equation. Okay, so this is the stuff that we did last class. We take a look at this. All right, well, I think what I want to do is I want to be able to find the growth and the starting value. So I'm going to go back up to the table and try to find the growth. Now, I would like, ideally, and it is going to be at this point, that my x's are all going to differ by 1. So it looks like +1, +1, +1, +1, all the way across, which it does. That's good. Yes, they will get more complicated, but that's why we're training our eyes right now to make sure that we look at both x's and y's. Okay, at the bottom, it looks like this is consistently increasing by 5. So if the x's are +1, +1, +1, +1, +1, then that means that the growth can be taken specifically from the y's. So let's go ahead and state our growth down here. So our growth is going to be +5. Okay, back to the table. I want to be able to find my starting value. And you guys hopefully recall from last couple classes, that the starting value is identified by figure 0. So if we take a look up at the table, and we're going to take a look at where figure 0 is located, and figure 0 has 2 tiles in it. So the starting value is going to be those 2 tiles. All right, now that we have that information, let's go ahead and write the equation. So we get y equals, okay, growth times x plus starting value. So that's our equation. But I do want to push this just a tiny bit further. On the previous question, we were asked if it was a function or not, and we agreed absolutely yes, this is a function because passive vertical line test. Every input has exactly one output. There's a whole bunch of different ways to describe this, but the answer was yes, it's a function. If it is a function, then that means that we can write the equation in function notation. So I want us to copy down this equation. Leave the y alone though, don't touch it. So don't even bring it with you. Bring down the 5, the x, the plus, and the 2. But since this is a function, we can call this f of x. We can use that fancy notation for y. But we only get to use f of x because this is a function. So actually, either of those equations are correct because they're technically comparable to each other, whereas the second one just has the special name for y. Okay, so on this screen, I wanted to make sure that I gave you a review of some definitions. Now, it is my understanding that x-intercepts and y-intercepts were taught in either Math 7 or Math 8, I believe, but I did want to remind you what they were. So if it were me, it'd probably take a minute or two. Make sure that you have the top stuff written down with the sample graph off to the side. You'll also notice that I color-coded them. So the blue point on the graph on the top goes with the blue writing at the top. Purple point goes with purple writing. Okay, so let's take a look at 5A and 5B using the information up at the very top. And I am going to color code to match on this page. So the x-intercept is wherever the graph itself hits the x-axis. Remember, the x-axis goes sideways. So if we take a look at 5A, it looks like it hits the x-axis at my blue dot that I just put on there. So to write my x-intercept, your x-intercept is always going to be written as some number, comma 0. By definition, because if we were to plot that point, we would go right or left, however many, but then we wouldn't go up or down at all. That's why we would have the 0 for the second component. So if I take a look at where the blue dot is located, it looks like it was left 2, so negative 2. Okay, let's take a look at the y-intercept. So we take a look at the graph, see where the graph crosses the y-axis. Remember, the y-axis runs vertically. So we're going to go up to that location. I'll put my purple dot there. Okay, so that means then that I can say my y-intercept. Well, my y-intercept is 0, comma some number. 0 because when I start from the origin, I don't go right or left at all. So there's no x movement. Then I either go up or down to get to the graph. And it looks like that points up at 4. So I've got my x-intercept and my y-intercept. All right, let's go over to the other one. So x-intercept, I'm going to go, well, it's going to be something, comma 0. Because I'm going to go right or left, but I'm not going to do any up or down part of it. So in this case, it looks like it's over at the blue dot, which looks like it was right. So it's positive 6. Okay, my y-intercept. The y-intercept is 0, comma something. So remember, there's no right-left movement, just up or down. So if we take a look at this graph, it looks like it's going to be down. And since it was down, it's negative. And it looks like it's 3 units. Now, before we move on to the next slide, I want you to take a look at the y-intercepts on both of these. Something interesting is here, and we're going to use this to help ourselves out. So the y-intercept specifically, and it's something special about that y-intercept. What makes the y-intercept interesting to us at this point is the format of the point itself, the 0, something. So I want you to think back to the tile pattern stuff that we've been doing. If we had a point in a table, so let's do a little miniature table here. If we had a point there, or if this was X and this was Y, if we had 0, some number, whatever the number is, this was telling us that it was the starting value. So whatever the number is, that represents the starting value. Well, interestingly enough, if the starting value is always 0, something, and the y-intercept is always 0, something, then we can say that the y-intercept helps us find the starting value. And that's pretty big. So I'm going to go ahead and highlight that because this is pretty interesting information that's really going to be super helpful to us as we transition on to the idea of looking at graphs specifically. So we'll stay on this slide for about 30 more seconds and then we'll move on to the next one. So here are more images that were linked to the agenda, so make sure that you have them in front of you. We've got a whole bunch of stuff that we're going to do. We want to be able to state the growth, the starting value. We want to write the equation, determine if it's a function. If it's a function, write it in function notations. There's kind of a lot of stuff, which is why I color-coded it all up at the top. All right, so if we take a look at this, I want to be able to use the graph itself, but I think we need to take a little transition to a table first, so kind of get back to what we know. So what I'm going to do is I'm going to go ahead and just create a small table for us using some of the values that I see. So I'll go ahead and make a table here. All right, so there's our X, there's our Y. All right, I already see some points that are plotted, so I'm going to go ahead and use those. So I see one is at 0, 3. So I'll use that. I like that point too because of the 0, aspect of it. And I do want to try to stick with the X's only increasing by 1. We'll definitely get to ones where the X's kind of jump further, but in this case, let's do +1, +1, +1. So I would like to go +1, then I'll go +1, and then I'll go +1. And then I think I can find all of those in my table or in my graph. All right, so at 1, it looks like I'm at 5. So I've got the 0.15. At 2, it looks like it crosses at 7. So I've got 2, 7. And then I think I can look at the table and try to predict what's going to happen based off of the growth that I see happening in the Y's, which I think this is going to be 9. And if I look at the graph, yep, it's right up there at 9. Okay, now I'm going to use my table to be able to identify the things that I'm being asked for, but then I want to relate it back to the graph. So first thing is the growth, okay? I want the X's to go +1, +1, +1, +1, which they do. That's good. So now I'm going to look at what's happening with the Y's, and it looks like all of those are +2. All right, so I can say what my growth is. So remember, if it is +1 for the x's, +1 very specifically, then I really only have to look at the y's, which is kind of nice. Okay, so there's my growth. All right, my starting value. Well, my starting value, hopefully I can see in the table, which I can because it's the Y-intercept. So if I take a look at the table, I want to find 0, comma, and the number that comes next, so the y that comes next, that's my starting value. So my starting value is going to be 3. Okay, I've got plenty of information now to write the equation. So I've got y equals, okay, the growth x plus the starting value 3. Okay, next thing I need to be able to do is determine if this thing's a function. We'll take a look at the graph. Looks like a function to me, passes the vertical line test. You can even say that every single x has only one y or exactly one y. So yes, definitely. So every input has exactly one output. All right, so that means that I get to write this in function notation. So remember, all we're going to do is we're just going to bring the growth and the x and the plus and the starting value down. We're just going to replace the y with f of x. There we go. And I think we just addressed all of the questions that they wanted us to do for this. So that's A. But I want to take a look at the graph and see if I can extract the information without actually having to make a table. So let's see if we can find the growth. Well, remember what I said in the table. We want the x distance to be +1, +1, +1, +1. So I'm going to use the points that are given to me there. We'll see that the horizontal distance, so from left to right, is +1. Left to right, +1. That's good. That's the x is going +1. Now what I'm going to do is I'm going to count the vertical portion of it. So from bottom dot to top dot, that looks like +2. Bottom dot to top dot, +2. And we want it to be consistent. So +2, +1. So I know that my growth can be found by the up movement, but only because it's +1 in the x direction. It does get more complicated than this. Remember, I keep saying that. We'll get there. But for now, we want this to be +1, so from left to right, and then we want the vertical portion. We want the vertical portion to represent our growth for us. So I can see the growth in the graph. Okay, so what about the starting value? Well, the starting value, like we said on the previous page, was the 0, comma something. That's the y-intercept. So if I take a look at the graph, I can see the y-intercept right there. Now the y-intercept would be written as a point, 0, comma 3. The starting value is just the 3, okay? Okay, so why don't you try B and see how you did. Okay, so double check your B against mine and hopefully we match. It does take practice, just like everything else that we do. So hopefully we're feeling a little bit more confident about this. If not, make sure you go back and rewatch this, maybe a little bit more work with part A. But at this point, see if you can do part C. Okay, so double check your part C against mine. One of the things that I did do, because the growth was 1, remember you're looking at the vertical movement, since the growth was 1 and I put it in front of my x, so it looks like 1x, you guys know that the 1 in front isn't necessary, so we can actually drop it. But either of those equations would be totally acceptable, and I'll show you what I mean. So I just put a red box around them. You can have it as y equals 1x plus 3 or y equals x plus 3. But then, yes, this is a function because every input has a unique output, so it only has one. And then I can rate it in function notation as well.